This video is going to discuss how to solve quadratic inequalities, and I'm assuming you have already taken Algebra 1 before, but the basic idea is you are going to be seeing things like x squared plus 3x plus 2 is greater than 0, and then you have to solve that. So I'm assuming you know how to factor a trinomial like that, so let's just go ahead and get right into it. Here's the basic procedure. You are going to factor to solve, and then use the zero product property to create your solutions. And the basic idea of how to create the graphs with shading. We're going to be drawing some number lines and shading some graphs. Maybe just pause the video, quickly write this down. If you have the less than or the less than or equal to signs, we call that an and problem. And if you have the greater than signs, we call that an or problem. And for and problems, you shade the middle. For or problems, you shade the outside. So let's just go ahead and do one of these and then take it from there. X squared plus 2x minus 15. Let's go ahead and factor this situation here. 5 times negative 3 would be your answer for your two numbers to create your binomials. And then using the zero product property, we're going to be getting 3 and negative 5. Let's put it on a number line. Negative 5 is less than 3, so negative 5 would go on the left. And then once again, because we have the less than or equal to sign, the variable is on the left. Wait, where's that? Yeah, there we go. The variables are on the left. Let's just jump right back over here. This is what I'm talking about when I said, hold on. When the variable is isolated on the left, these are the rules. So we are currently in a less than situation. So we are going to be shading the middle of the graph. And then also because we have the or equal to's, you're going to notice how those circles are shaded in. And that's it. That's all you're doing. You're basically just factoring, and then you're putting your two numbers on the number line, and then you are shading accordingly. If it is the less than sign and problem, shade the middle. And then let's look at a greater than example right over here. So take note of the fact that we have a GCF that we could factor out to begin things, and that GCF would be negative 3. You do all of that, start your factoring. You got your 16 and your 10, you got an 8 and a 2, write down your binomials, zero product property. And there you go with negative 8 and negative 2. Remember, greater than sign means it's an or problem. You're going to shade the outsides. So there are answers, negative 8, negative 2. Negative 8 is less than negative 2, so negative 8 goes on the left. We have the greater than sign. There is no line underneath it, meaning these circles are going to be open. And then because it is the greater than sign, it is an or problem, and you shade the outsides of your number line. That's all you need to know. That's the basic idea. Let's do another one. So now we're going to solve inequalities, but we're also going to use interval notation when we set up our answers. And a quick reminder of interval notation as it pertains to inequalities is written right here. Write it down. Basically, the or equal to signs means you're going to have brackets. And if you just have the regular inequalities without the lines underneath, you're going to be using parentheses, and that pertains to your interval notation. Before we begin, always remember, set your quadratics equal to 0. So in number 3, let's subtract 20 from both sides, and now we have it less than or equal to 0. So I guess whatever, less than or equal to equal sign, whatever, you get the idea. Let's factor. You do have negative 20, positive 1, you get a 5, negative 4, do the zero product property, and there you go with your answers. Remember, it's an and problem because we have the less than sign, and with an and problem, you shade the middle of your two numbers on the graph. And then for your interval notation component, remember that if we have the or equal to signs, you are going to be using brackets, not parentheses. And we have that for, we have shaded in circles for both of those numbers. So that's why you can see the brackets right here for the interval notation. And then the way of writing the inequality is directly below. It is an and problem, so the x is always going to go in the middle. All right, number 4. Add 35 to both sides. There's a GCF of negative 1, so factor it out. And then do your factoring. You got a negative 7 and a 5, and that work is correct. So zero product property, you get your x's is 7 and negative 5. And because it's greater than, It's an or problem. Shade the outsides of your graph, the outside parts. And because you have the greater than sign, there is no line underneath it. Your interval notation is a parenthesis. It is not a bracket like in the previous one. Bracket means the or equal to sign was used instead. And that is pretty much all of the lesson. I think we got one more thing. Infinite versus no solution. This was talked about in my previous video, but really quick. If you have gotten the absolute value bars all by themselves, so let's say you have those bars right there. If they're all by themselves and on the other side of the inequality is a negative sign, then you know when you have the greater than sign, you will have infinite solutions. And in this situation, the less than sign would mean there is no solution. But this video didn't really talk about that, so I don't know why I put this slide at the end. Whatever. Important thing to know with the absolute value inequality stuff. All right, here's some practice problems. So go ahead and take these down, pause the video, give them a shot, and do the whole thing. You want to draw your number line, use interval notation, write out the inequalities. And I'm just going to go ahead and let this play through at a slower speed. There we go. All right, thanks for watching.